Hey guys, in this video we're going to start the process of working through the ACT one page at a time. This first page has problems 1 through 7 on it, so knowing that there's 60 problems on the test and you get 60 minutes to complete them, so about 1 minute per problem, our goal would be to be able to do these problems in about 7 minutes, maybe a little bit less because this is the first page, so hopefully these are a little bit easier or quicker problems to complete, but about 7 minutes. As we work through these problems, I'll give you a couple seconds to pause the video and try the problem at your own pace. Maybe time yourself and see how long it takes, but try each problem. The best way to get better at these problems is to just try them, right? So try it on your own first. I'll work through the problem and you can compare your work to mine. If you made some mistakes, see where you made some mistakes, and we'll just keep going. For each problem, I'll also mention which topics are particularly relevant. So the ACT is broken up into different subcategories of like types of problems, so we'll talk about that. And then if there's any particularly relevant test-taking strategies, we will also mention that along the way. I do also have timestamps in the description, so feel free to skip around in this video if there's a specific problem you're looking for. All right, so here we go. So number 1 says the numbers 1 through 15 were each written on individual pieces of paper, one number per piece. Then the 15 pieces of paper were put in a jar. One piece of paper will be drawn from the jar at random. What is the probability of drawing a piece of paper with a number less than 9 written on it? All right, so go ahead and pause the video, try this problem out yourself, and then I'll demonstrate how to do the problem myself. So before we jump into actually doing any kind of work, I like to dissect the problem and see what is important for us to understand in order to do the problem. So it's asking what is the probability, so we need to understand what probability is. And I like to think of probability as wanted outcomes over the total outcomes. So in this case, we have the numbers 1 through 15, right? So there's 15 total outcomes. And what are the wanted outcomes? It says, what is the probability of drawing a piece of paper with a number less than 9? Okay, so we also have to clue into the fact of saying less than, not less than or equal to, right? So 9 doesn't count. We're not including that, just the numbers less than it. So 1 through 8, which means there's 8 numbers, right? So 8/15. So the ACT categorizes this problem under IES, which is integrating essential skills, and modeling. We also had to understand probability and then the difference between like a less than or equal to type of situation. Number 2 says, which of the following expressions is equivalent to negative 4x cubed minus 12x cubed plus 9x squared? Take a second and try this problem on your own, and then we'll check our work. All right, so as far as vocabulary in this problem, really the only key thing we need to understand is equivalent. So if we have something equivalent to this expression, it just means like it's the same thing, just written differently, basically. So I noticed that we've got negative 4x cubed and negative 12x cubed. Those are the same type of term, or they're like terms. Let's combine like terms. That's probably what you've heard in a math class, right? Combine like terms. So if we have negative 4 and negative 12 of something, that's going to combine to negative 16. So we have negative 16x cubed, and then that plus 9x squared doesn't really do anything. It just stays there. It can't combine with anything else. And if this was like in a math class, I might be tempted to try to factor this or something, but we don't have to. If you look at the answers provided, we can actually see that we have it already. So the answer here is J. The ACT categorizes this problem under algebra. All right, moving on to number 3. It says when x equals 2, 10 plus 3 times the quantity 12 divided by the quantity 3x equals what? Which really is a mouthful to say, but it's really not too bad if you just try this on your own first, and then we will check our work. All right, so it's not mentioned in this problem, but really one of the key things is order of operations here. And ACT categorizes this under integrating essential skills. So we're going to take x, which equals 2, and we're going to substitute it into where it goes in this expression. And we just need to do order of operations. So let's see, I'll just rewrite it first. 10 plus 3 times 12 divided by, and then 3 times 2. So I'll just put the 2 in parentheses. That's where the x went originally, and that should do it. So we're basically going to work our way from the inside of the problem out. So 3 times 2 is 6. And now we have to do 12 divided by 6. 12 divided by 6 is, of course, 2. And so now we're doing 3 times that, and eventually we'll have to do 10 plus whatever that is. 3 times 2 is once again 6. So 10 plus 6 is 16. So the answer is B. With order of operations being something you learn early on in your math classes, ACT categorizes this problem as integrating essential skills. Number 4 is just a numerical expression that we have to find the value of, or evaluate it. It says the absolute value of 6 minus 4 minus the absolute value of 3 minus 8. And we have to find out what that equals. Go ahead and pause the video, try this yourself, and then we'll check answers. So this problem requires you to understand what absolute value bars mean, what they do, and then I guess a little bit of order of operations is included here, just like in the last problem. So absolute value bars kind of function like parentheses. They group the stuff inside them. We're going to have to do the stuff inside first. But what absolute value bars really do is they just make anything that comes out of them be positive, even if the thing inside was negative. So if we do 6 minus 4, that's 2. The absolute value of 2 is just 2 because 2 is already positive. And then we have a minus there, and 3 minus 8. So the absolute value of 3 minus 8, right? 3 minus 8 is negative 5, but the absolute value of negative 5 is actually positive 5. So we have 2 minus, and then the absolute value of negative 5, which is just 5. So 2 minus 5 is negative 3. So the answer is G. Again, ACT categorizes this as integrating essential skills. Number 5 says the expression quantity 4c minus 3d times quantity 3c plus d is equal to. So go ahead and pause the video and see what you come up with. I'm going to demonstrate 2 different ways of doing this problem, which is really just 2 different ways of organizing your work. We should obviously get the same answer both times. But 2 good ways of handling this are either something called FOIL, it's usually referred to as FOIL, which just stands for first, outside, inside, last. So it's kind of just directions of what to do in a problem like this. And the other way is the box method, which I've actually come to really like over the years of teaching. So I'm going to demonstrate this, and then I'll show you FOIL later. You can skip ahead to FOIL if you prefer that. But what we do here is we're going to draw a 2 by 2 box because there's 2 things in each set of parentheses. These are each binomials. And then we're going to put 4c minus 3d on top and 3c plus d on the side. It doesn't matter which one goes where, but they do need to be grouped the same way they are in the problem. And now what we do is we just multiply straight into the box. So 4c times 3c would be 12c squared. 3c times negative 3d is negative 9cd. 4c multiplied times d is just 4cd. And then the last box is d times negative 3d. So negative 3d squared. So now we have all of these terms and we just need to combine like terms. So the first box has 12c squared. And then these are actually like terms, negative 9cd and positive 4cd. If you add those together, that would be negative 5cd. And then there's a negative 3d squared at the end. So if we look for our answer, looks like we get C. All right, now if you prefer the FOIL method, which again stands for first, outside, inside, last, we're just going to multiply these things together in that order. So the first terms, the 4c and the 3c, if you multiply those together, you get 12c squared. And then O is for outside, so 4c and d, those are the outside terms. If we multiply those together, we get 4cd, and that's positive, so I'll put a plus sign there. I is for inside, so the 2 inside terms, that would be negative 3d times 3c, so negative 9cd. And then L is last, so the last terms, negative 3d times d is negative 3d squared. And just like in the last method, we have to combine like terms, so 4cd minus 9cd is negative 5cd. We also have minus 3d squared and 12c squared. So again, you can see the answer is C. In this problem, we multiplied 2 binomials together, and the ACT classifies that as just algebra. Number 6 says, of the 180 students in a college course, 1/4 of the students earned an A for the course, 1/3 of the students earned a B for the course, and the rest of the students earned a C for the course. How many of the students earned a C for the course? All right, so I'm going to visualize this as kind of like a pie chart. And we have 180 students total. Now it says 1/4 of them earned an A, so that's this many. And then 1/3 of them earned a B. So if I were to imagine dividing this up into thirds, equal thirds, might be something like that. So 1/3 of them earned a B, and what we want to know is how many earned a C, which is the rest, all of these. So I think the easiest way to do this is first figure out what is 1/4 of 180. So 1/4 times 180. You can either use mental math or a calculator there to get 45. And then 1/3 of the students earned a B, so 1/3 of 180, and that gives you 60. So we want to take the total 180, but then subtract off the 45 and subtract off the 60 and see how many are left. And if you do that, you should get 75, which is F. And the ACT categorizes this as integrating essential skills and modeling. And I just want to point out that when you're taking the test, you might not need to draw a diagram for something like this. When I'm explaining problems, I do like to draw diagrams just to help you visualize it. But another thing to think of is as you're reading through these problems, if you can get in the habit of drawing or writing out important information as you're reading through that, it can really help you to focus your attention on what you're doing and give you an idea of what to do if you'd otherwise be stuck. All right, number 7. This is the last problem on page 1. So this is the last problem we'll do in this video. So number 7 says, the number of fish F in Skipper's Pond at the beginning of each year can be modeled by the equation f of x equals 3 times 2 to the x power, where x represents the number of years after the beginning of the year 2000. For example, x equals 0 represents the beginning of the year 2000, x equals 1 represents the beginning of the year 2001, and so forth. According to the model, how many fish were in Skipper's Pond at the beginning of the year 2006? All right, this problem shouldn't be too complicated. Since we're looking at the year 2006, that means x would equal 6, and we're just going to take that and plug that into this expression. So 3 times 2 to the 6th power. And because this is in parentheses, and also because it's an exponent, those are both things that happen early on in order of operations, happens before multiplication, right? So we're going to do 2 to the 6th power first, which is actually going to be a pretty big number, and then multiply that by 3. 2 to the 6th power just means 2 times itself 6 times. So you can visualize it this way if you need to. And you should get 64 from that. You could also just use a calculator. So 64 times 3 is 192, so the answer is B. And ACT categorizes this as functions and modeling. Now for this problem, I just want to mention a test-taking strategy, and that is to kind of skip around when you're reading a problem like this. If there's a lot of text, sometimes you don't really need to read all of it. For example, the sentence that starts with, for example, we really didn't need to read that. If it said that the number of years after the beginning of 2000 is what X is, like, I think you probably just understand that. You don't really need to read all that. Also, try skipping to the end of the problem and read what the question is first, because you might not really need to read the problem at all. It just says, according to the model, how many fish were in Skipper's Pond at the year 2006? So, you do need to read a little bit to understand that X equals 6, but for the most part, you can kind of just figure out, okay, yeah, plug 6 into this and then see what you get. You can just type the whole thing into a calculator.